Dear students, today I have come up with a new concept of mechanism of reduction of carboxylic acids in the presence of lithium aluminum hydride. So this is the topic is taken from alcohols and phenols of class organic chemistry, class 12th organic chemistry. So here the carboxylic acids, when carboxylic acids treated with lithium aluminum hydride, so then followed by hydrolysis, we get primary alcohol. So this is nothing but reduction process. So what is meant by reduction? Reduction is addition of hydrogen atom and removal of oxygen. And for this, we need a strong reducing agent, particularly for the carboxylic acid, reduction of carboxylic acid. We need a strong reducing agent. So that is lithium aluminum hydride. So and sometimes we use other reducing agent also, which is called sodium borohydride, which is a weak reducing agent. And sometimes we select other reducing agent like catalytic reducing agent. So metal like nickel, so platinum, palladium also we use. And but for the conversion of carboxylic acids into alcohols, so we need a strong reducing agent, that is lithium aluminum hydride is so best suitable one in dry ether, so medium. So we have to treat the carboxylic acids with the lithium aluminum hydride so that we get primary alcohol. And if you analyze the reaction mechanism of this, so reduction of carboxylic acids with lithium aluminum hydride, so it follows hydride mechanism particularly. So how this now let us see this. So how the mechanism goes, and before formation of this alcohol, and let me discuss the mechanism in detail. So the mechanism of carboxylic acid reduction by lithium aluminum hydride. So when the carboxylic acid, any carboxylic acid is treated, so RCOOH is treated with lithium aluminum hydride in the first step. So since acid so react with the metal present in the lithium aluminum hydride, so it can release hydrogen gas. So then the lithium salt of carboxylic acid is formed in the first step. So then apart from this aluminum hydride and hydrogen gas is liberated. So this is the reaction like similar to acid base reaction, we say acid base reaction where the acid react with the metal and releases hydrogen gas. So then aluminum hydride is formed. So one hydrogen gas is liberated in this. As you know that aluminum hydride is Lewis property, it has electron deficient. So electron deficient hydride we say. And now in the second step, so what happened in the second step? So the produced aluminum hydride, so which is electron deficient, so this will be attacking the salt of carboxylic acid. So when the hydride of aluminum attacking the salt of the carboxylic acid, so then there is a hydride shift will takes place. So the hydride shift takes place to the electrophilicity of the carbon here. So when the hydride ion, so when see here the aluminum hydride will be attacking the oxygen atom of the carboxylic salt. So when since it is electron deficient, so oxygen donate one lone pair of electrons to aluminum. Then between oxygen and the carbon, the pi bond will delocalize. Then the carbon get electrophilicity, positive charge. So because of this carbon get electrophilicity, so one of the hydride from the aluminum is moving toward the electrophilicity of the carbon. Then so we get a tetrahedral intermediate compound is formed. This tetrahedral intermediate compound, so again the undergo resonance, the negative charge from the oxygen move between this carbon and the bond between oxygen and carbon is dissociated. So then, so we get this compound tetrahedral intermediate stabilized into aldehyde by undergoing dissociation. So so we get the aldehyde. So compound we get. So and when this aldehyde further subjected to treating with so lithium aluminum hydride, so then there is a nucleophilic attack will takes place. So and this hydrogen, this hydride will be shifting again to the electrophilicity of the carbon, then the pi bond moving on to this oxygen. So then hydride shift is second hydride shift or a nucleophile shift taking place to the aldehyde. And in the next step, after this nucleophilic attack, so after this, next step will be, so after the nucleophilic attack of the hydride to the aldehyde molecule, so next, so again, when the hydride shift is taking place to this carbon, then so aluminum hydride electron deficient molecule is formed. This electron deficient molecule will attack the oxygen. So we'll attack the oxygen here. So then again, so between the aluminum and oxygen bond is formed. So then it is subjected to again hydrolysis, acid hydrolysis. Then we get so primary alcohol we get, because so the hydrogen so proton is shifted to the oxygen here. Then aluminum, so means lithium combined with hydroxide, lithium hydroxide is formed. Then aluminum, so combined with acid, which is added sulfuric acid or HCl is added, then aluminum sulfate salt will be formed, or lithium hydroxide is formed as a byproduct. So then, and so one of the hydrogen when shifted to this oxygen will form so primary alcohol we get, so by this reduction process. So mainly the reduction takes place in two steps. One is addition of lithium aluminum hydride. So then followed by the hydrolysis, acid hydrolysis, then we convert the carboxylic acids into primary alcohol. And in this, so we should add the hydride twice. So we should add the hydride so twice to the so once to the carboxylic acid, then once to the aldehyde, so that we get the primary alcohol. It is based on hydride shift. So that is. Thank you.